We're given a vector field F. We want to see if it's conservative, and if it is, we want to find the potential function. So we'll write it in terms of i's and j's. So we have y e to the xy plus y times I plus x e to the xy plus x minus 1 times j. We want to set the partial derivatives, or find the partial derivative. So we'll call this thing f1. We'll call this f2. So we'll take the partial of f1 with respect to y, which is this thing right here. You have to use a product rule for y e to the xy, and so this is the answer. Now we're going to take the partial derivative of f2 with respect to x, and notice we get the same answer. So these two derivatives are the same, and therefore we say that f is conservative. Now we want to find the potential function. So recall that the vector field is equal to the gradient of f. So this is basically partial of f over x, partial f with respect to y. Okay. So you're going to set each one equal. So the first component is equal to the partial of f with respect to x. Now we have to integrate with respect to x. So y is treated as a constant. So we have e to the xy plus xy. But now you always have to add a constant. So the constant here is a function of y, since we're integrating with respect to x. Similarly, we'll do the same thing, but now with partial f with respect to y on the second component. Integrating with respect to y, we get a function of x. And so now we just compare our two f of xy's. We see we have e to the xy, we have xy. This is a function of y, but this has to be a function of y. And then we have a function of x. Well, there is no function of x here, so we'll just turn that into a constant. So our potential function is e to the xy plus xy minus y plus c.